This is a review for Unit 12. What you'll notice about this trinomial, if you tried to factor out a GCF, there isn't one. So you have to factor it even though your a value here is bigger than 1. There's a couple different methods we looked at. I'm going to show you some of them throughout this review. First, let's try the slide and divide. For the slide and divide, you take that 5, you slide it over here, and this becomes 180. So this part right here was 36 times 5. I'm going to use the x method now, put 180 on top and 36 on bottom. Guessing and checking with your calculator will help you. Just try dividing 180 by different single-digit numbers. If you divide it by 6, you'll get 30. Turns out those are the two numbers. So like normal, we would write it like this. But then we're going to divide. And we're always going to divide by a. Here, a is going to be 5. So on the left, this will become 5x plus 6. And the right, this will become x plus 6. And that's our factoring. Let's look at a similar process using the Xbox method. On the top, we write a times c, which is going to be negative 6. On the bottom, we write b, which is going to be negative 1. It's that value right there in front of x. To figure out which two numbers work here, we're going to try negative 3 and positive 2. And we write those over here like this. Next up, the original a term and c term get copied into the box, and we guess and check. 2x and x have to go like this, because if I was to put 2x here, it wouldn't go evenly into the 3, so it lines up nicely here in this row. This is going to be a negative 3, because x times negative 3 gives me this. And this will have to be a 1. So I can write out my answer as 2x minus 3 and x plus 1. So two different methods. They work very similar. Notice they have the same x. It's just how you find the actual factors varies. Either you're dividing by your a term, or you're using this box method in reverse. So let's slide this over. And on the top here, I'll have negative 24. On the bottom, I'll have negative 2. This means I'm looking at negative 6 and 4. If I write this as x minus 6 and x plus 4, I'm going to divide by my a term on both sides. This becomes x minus 2, and this becomes 3x plus 4. So what happens is, when you don't get a whole number, you simplify as much as you can. If this was like 8 over 6, for example, you would turn it into 4/3. And then this 3 slides in front of the x. So 1, 2, and 3 all wanted you to factor. And 4 and 5 want you to solve. So you have to do the same thing plus an extra step. The other thing that's new here is they're not already set up for factoring. First, you have to get them equal to 0. So for example, we can add 8x to both sides, and we can add 9 to both sides. And this gives us 6x squared plus 13x plus 2 is equal to 0. You can't even start this problem until you move all this over to the left first. Then let's think about the slide and divide method. I'm going to slide the 6 over here, so if I do the x, I have a 12 on top and a 13 on bottom. So it's going to be 12 and 1. So if I write x plus 12 and x plus 1, I have to divide by my a term. Here this is going to be x plus 2, and this will be 6x plus 1. To find out what the actual zeros are, I can take these factors and set them equal to 0. X plus 2 equals 0. Or in other words, my 0 is negative 2. My next factor, 6x plus 1, I can set that equal to 0. And if I subtract 1 from both sides and divide by 6, this is my second 0. So when it says solve, most of the steps are the same, but we take those factors and we set them equal to 0 separately to find our answers. Sometimes it's just like before. It's the opposite. So if it was x plus 2, you plug in a negative 2. But sometimes it's going to be a fraction. How do you find it? Set it equal to 0. Treat it like a two-step equation. Minus, divide. For this one, I'm going to subtract x from both sides, and I'm going to add 4 to both sides. Now you might notice that there's nothing to subtract x from, which is okay, because then it's just a unique term. So if you move over these values correctly, everything on the right is canceled out. Now it's a 0, and everything on the left is adjusted accordingly. I'm going to slide over the 6, so if I was doing my x method, I have negative 12 on top and negative 1 on bottom, which means my two numbers are negative 4, positive 3. If I think about x minus 4 and x plus 3, I have to divide by my a value, which is 6. Notice neither of these comes out even. So this is the case where I have to simplify the fractions. So this becomes x minus 2/3, and this becomes x plus 1/2. Notice then I can slide the 3 over, and this is a factor, and I can slide the 2 over, and this is a factor. But I think a more useful approach would be to think about the zeros. 2/3 is a 0. Negative 1/2 is a 0. They're just the opposites of these fractions. If you wanted to find them the long way, you certainly could do 3x minus 2 is equal to 0, 3x is 2, x is equal to 2/3. Or you could do 2x plus 1 is equal to 0, and you eventually end up with these same answers. So, if you're not required to go to factored form, you might as well stop here and just think that they're the opposites. There's your answer. Since it's minus 2/3, the answer is 2/3. Since it's plus 1/2, it's minus 1/2. But if you're in factored form, you set them equal to 0 and solve. Either way you do it, these are your actual solutions. On the back, we're looking at difference of squares. The difference means we're always going to be looking at subtraction. And this part means we're going to be looking at perfect squares. So these are numbers like 4, 9, 16, 25, and it's also exponents like x squared, x to the 4th, x to the 6th. We won't see any odd exponents. And the premise is, if we have something like x squared minus 9, we can figure this out by doing this. Notice what happens in the box method. X times 3, or x plus 3 times x minus 3 gives us x squared. This is 3x, this is minus 3x, and this is minus 9. This diagonal cancels out when these are the same number, but one is positive and one is negative. That's why this strategy works. Now, how do you actually use it? Well, think about the square root of 100. That's 10. On the square root of x squared, that's x. So you write it as 10 plus x and 10 minus x. So it always has to have that pattern where the first one is plus and the second one is minus, and they're going to be the same values otherwise. If you wanted to check your answer, you could go back and use the box method. 10 and x and 10 and minus x, and you'd find 100, 10x, negative 10x, and negative x squared. Notice these cancel out, and you are left with 100 minus x squared, which is right back where we started. That means you did it right. You don't have to do that, that's just a check. So for number 7, let's start with what it's going to look like. We're going to have two factors like this. The first one I'll write a plus, the second one I'll write a minus. What is the square root of 121? That's 11. That's going to go in the first spot. What is the square root of 49x squared? That's going to be 7x. We'll write that in the second spot. There's our answer. So this will be y plus x times y minus x. Notice that the exponents just get cut in half, but the pattern continues. So if I have a larger exponent like 4, this is x squared plus 7 times x squared minus 7. So the square root of x to the 4th is x squared. And the square root of 49 is 7. And then I keep it in that same pattern where I have a plus and I have a minus, and they're the exact same factors otherwise. The last one, when I have an x to the 4th, let's draw an x and put negative 36 on top and negative 5 on bottom. 9 and 4. The 9 will be negative, but instead of writing x minus 9 and x plus 4, I'm going to write x squared. Because notice, these both had extra x's. So these are the two factors of this larger polynomial. And this one just carries down exactly as it was. But this one on the left, we check our list. Is this subtraction? Yes. Are these perfect squares? Yes. So we can actually shorten this, or not shorten it exactly, but split it further. So this one, using the difference of squares shortcut, becomes x plus 3 times x minus 3. And there's our final answer. The one on the right does not work that way because this is addition. And addition, it's the difference of squares shortcut, not the sum of squares.